We are going to start off with our very first speaker, Sandeep Kumar. Sandeep is a principal solution architect at AntStack. He has a passion for serverless architecture and is a AWS SA Pro certified with 5+ years of experience in building serverless applications. His topic for today is LamRAG, from data to constructive insights using Amazon Bedrock. So please help me in welcoming Mr. Sandeep.
Yeah, hi everyone. Uh, my name is Sandeep. I work as a principal solution architect at AntStack, and today my talk is on a concept called LamRAG. So basically what we'll be doing is we'll be taking an application that we have built internally, and we'll see how to integrate different parts of AI to the application. So again, my name is Sandeep. I work as a solution architect, and I've been developing serverless applications for the last 6 years. Yeah. So let's start with the problem statement that we had. So at AntStack, we build serverless applications for our clients. So at any given point in time, we have multiple projects running. We are building the applications for different clients. Now, each of these clients is going to have a different schedule in terms of sprints and project management and things like that. And again, all of them have different project managers as well. So what was becoming a headache for us is how to get the feedback at the end of every sprint and how to make it useful. So we being an engineering first company, instead of going and looking for a product out there, we decided to build the product ourselves. So that's when we thought we will build an application that is going to collect the feedbacks, that is going to keep track of sprint schedules and all those things. The other problem we had was with the feedback itself. So when we started asking people to give feedbacks, all the comments were, looks good to me. It's just straightforward, everything is good, everything is great, there are no issues with anybody. And then we got a little smart, we said, okay, let's remove the comment and ask people to rate other folks from 0 to 10. Surprisingly, everybody got 10 on 10 ratings. Now we had to figure out a way, how do we get out of this and make sure the feedback is actually useful and helping the other person out. So that's when we thought we will try Bedrock. Now, what we started with Bedrock is a simple prompt. So the prompt looks something like this. So it's just going to be, I'm going to give you a feedback. Now you need to classify it on 3 categories. So for us, the 3 categories that worked out are positive energy, productivity, and reliability. So with these 3 metrics, we can identify who's doing good, who's doing not, and what kind of improvements that we need to look for. And at the end of this comment, we also provide the actual feedback that the person has received. And with this experiment, we saw that we were getting results. Now, to do this, we used Amazon Bedrock. Bedrock is, again, the generative AI service from AWS. So they have these playgrounds. They have chat. They have image playgrounds where you can test out different prompts and see how it works. So we started off with the chat playground. One cool thing about the chat playground is you can run the prompt, different versions of the prompt, against different LLMs. So we tried out with Llama, with Claude, and with other ones to see which one is giving the result that we were expecting. What we also got is the metrics. So how much time each of this LLM takes to process the request that we are sending, how much tokens it consumes, and with that, we also get an approximation of how much it's going to cost us. So with these experimentations, we found that at a particular point, we were getting the results that we were expecting, and all the system is working fine. But the problem is with consistency. The prompt that I showed earlier works good, but it doesn't work for all the scenarios. So if the feedback is a little not so good, then the system fails. So that's where we come into something called prompt engineering. So prompt engineering is basically making sure you have a solid prompt such that whatever input you provide, you still get the output that you are expecting. What is prompt engineering? Basically a set of practices or a set of guidelines that you need to follow to make sure the LLM always provides consistent results. So we start off like this. The first thing we need is a persona for the LLM. So in our case, we're telling you're going to be rating a feedback, you're a manager, XYZ, and then we provide an action, what it's supposed to do. So in our case, it's supposed to take the feedback and categorize it on 3 different ratings, which is positive energy, productivity, and reliability. Next, and this is a very helpful one, we provide references on the positive cases and references on the negative cases. So there are multiple ways to do it. This is the simplest way of doing it. As part of the main prompt itself, you can do it. Or there's something called as a few shot prompt. So in that, you start sending multiple prompts to the LLM with with different samples on positive cases and negative cases. So in our case, what we're saying is, if you're able to classify it, rate it from 0 to 5. If you're not able to identify that particular category, give it a rating of -1. So, and then what we will do is, in the backend, when we get a response of -1, we let the user know that the comment or the feedback that you have given is not matching our criteria. So update your comment and provide the feedback again. Then we provide variables. So variables are a neat way of inserting dynamic values that you want to the API. So in our case, the entire prompt remains consistent for all the users. The only thing that changes is the feedback that the user has actually received. So we mark that as a variable, and when we are calling the API, we just pass it on as a parameter for it to be processed. The next part is the output instructions. So here is where we define what kind of output structure we want to receive after the LLM call is complete. So in our case, we are telling give the output as a JSON, and the output needs to have 3 keywords, which is reliability, productivity, and positive energy. And it always needs to be a JSON object. Now, once we tested out this prompt and we saw that it is working, one of the ways to test it is using the prompt management console in Bedrock. So again, the prompt management console is an easier way for you to create and keep track of what kind of prompts you're making. It's easily accessible via the API. It just makes the entire thing much more simpler to use. So here again, if you can see the feedback variable, and at the below, I've given the test variables. This is where we provide the feedback. So we basically call this prompt, and whatever variables we have configured, we pass it on as a parameter. The other cool thing about the prompt management is it allows you to compare different variations of your prompt. And you can run them together and see what kind of responses you're getting and fine-tune your prompt according to that. Now, each prompt, you can create different versions of it, and which version you want to use, again, is part of a parameter that you send to the API request. Now, in these 2 cases, the only difference is this line which says, on the left it says be lenient with the ratings, and then on the right it says be strict with the ratings. So every single line that you write as a prompt affects what kind of outputs you're getting. So in the response, if you see, on the left side, it has taken reliability as 4, but on the right side, it has taken reliability as -1. So this is why you need to compare different variations of your prompt to see which one is giving the output that you're looking for. Another reason why we had to do this is once we had the initial prompt ready and we asked people to use the feedback system, eventually people figured out what kind of feedback they need to give for everybody to get a 5 on 5, which eliminated the entire purpose again. So then what we started doing is we started tweaking with the prompts. We keep changing this prompt or updating it once in a while so that the previous logic that the user has used to kind of get a 5 on 5 rating doesn't work anymore, and the system stays fresh. So this happened, and we integrated this part of the application. 3 months go by, and we have feedbacks from about 80 users for the last 3 months. Now, what do we do with this data? Ideally, it's reviewed by, say, a manager or somebody on the top level who's going to look for my feedbacks and see what kind of reviews I've gotten. Am I doing good? Am I doing bad? But we wanted to take it one step further and see, can we make it much more easier for the review process? And that's when we thought, we will send all the feedbacks to an AI and ask it to summarize it. So let's say if it is my profile and somebody wants to see my feedbacks, uh, the AI is going to have information on all the feedbacks that I have received. And one simple question, like, tell me about Sandeep, should give an answer like, he's doing good in this, he's doing bad in this, and needs improvement on these items. So that was the goal. And that's when we started using vector databases. Now, before we get into details of the vector database and RAG, some basics to kind of understand what it actually is. So let's start with a simple example. List some red colored fruits. Now, if this is your text, basically a vector is a mathematical representation of the data that you're providing, or of the text in this case. It's a set of numbers which are in an array. Each of that number represents one or the other property of what the input text is. Now let's go into dimensions. Let's say you have a fruit or multiple fruits. Let's take apple. And you have different properties of it. You have color, you have sweetness, you have crunchiness, and whatnot. And you rate them against a particular number from 0 to 1. Now, every index in a vector represents a property or a quality of the input that you're providing. So in this case, if the fruit is apple and you have a vector for it, the arrays would represent the properties like color, sweetness, crunchiness, etc. Next, indexes. Indexes are basically your entry point for the database on which it can do the search for the vector or for the question you're asking and provide the result. Now, what is embedding? The data or the text that you provide needs to be converted into vectors and stored in the database. Now, you can do it programmatically by yourself if the dimensions are limited and you know that the structure is not going to change. Excuse me. But in cases of LLMs, there is a standard set of dimensions that it creates. So if you take the regular ones that are out there, you get about 1026 dimensions or 512 dimensions. Now, for us, programmatically, even if we could split your data into 512 dimensions, we will not know what to do out of it. But that's where the LLM comes into picture. The LLM has a certain logic by which it decides what kind of properties need to go in what array of the index. And to do that, or that entire process is basically called embedding. So you provide a set of data to an LLM, and then it converts it into the X number of dimensions that you have specified, either 512,026 or higher than that. And that converted data is stored in the database. Now, what is RAG? Basically, the data that you have saved needs to be queried. Now, that is RAG. Let's say you have an input which says list some red colored fruits. Now, that is converted into a vector. Now, this vector is provided as an input to your vector database, which does a similarity search. So basically, it matches a particular array of numbers with another particular array of numbers. And whatever it finds is the most relevant or the nearest result is going to provide. So in this case, list some red color fruits is going to provide you the result of apple as the top priority because that has the most value in it. And all the other similar results or the nearest results that it can find, all those results will be provided. Now, this entire thing is called RAG. You providing an input that gets converted into vector, that goes into vector database to do the search, provides the similar results. Now, in Bedrock, you have an entity called knowledge base. So there are two ways of using the knowledge base. One is a chat with document, which is basically you upload any document that you have, PDF, JSON, whatever it is. And once the configuration is complete, you get a chat bot where you can directly ask questions on the chatbot for that document, and you will get the results. This is the easiest way to identify or to get started with a document and see what kind of Gen AI stuff you can do on top of a particular document. Now, the default way is to create a knowledge base. Now, this is a new update from nearby the reInvent. So the basic one is knowledge base with vector store. So that is basically creating a vector database for the particular data set that you're providing and getting the results. The next one, which is introduced recently, is a knowledge base with structured data store. So in case you're using data warehousing solution like Redshift, so you can provide that as a data source and use GenAI on top of it. So that's the second option. And the third option is Kendra. So with Kendra, you're able to do graph RAG, which is the next level of what a RAG can do, which is, think of it like this. You have RAG, which runs on a set of connections or similarities. And now you have another level on top of it, which is used to identify which is the best data that you're looking for. So we'll start with vector store. So when you start creating the vector store, the first thing you need to select is your data source. So these are the supported data sources as of now. And part of reInvent, there's also a new data source called custom. So for our case, what we essentially did is all the information, all the feedbacks that we have stored in a DynamoDB, we just exported it to a S3 file. And we gave that as the source. So we select S3 as the source. And then the next screen, you need to select something called as parsing and chunking. Now, what are these? If you're providing a JSON or if you're providing some simple text, all that can be embedded directly by Bedrock. There's no extra cost to it or there's no complication to it. It is done as long as you provide a valid S3 data source, it will do the conversion. But let's say you have a video file or you have an audio file or any kind of media content. So for those things, Bedrock cannot process them directly, but it gives you an option to select other LLMs through which you want to process that particular data and convert it into vectors. Next, you have chunking strategy. So when a file is, or when you select a data source, you need to say what kind of, or what sizes of data you want the vectors to have. So in our case, what we did initially was, once we uploaded the entire data set to DynamoDB, from DynamoDB to S3, we just selected default chunking to see what happens. Now what it did is, it took all the files from S3 and just randomly, not randomly, I think it's 300 tokens or something. So for those 300 tokens, it split those files into those small chunks and stored them in the vector database. Now, although this is fine, when we ran the chatbot and asked the query, like, tell me about Sandeep, it did give a wonderful response telling he's doing good, etc., etc. But it was not my data. Because the data set I had uploaded contains everybody's information. And when you go with default chunking, it does not know that it's different sets of data that needs to be stored. It just takes it as a singular data and splits it across based on the number of tokens you have provided. These are the different chunking options that are available. And what eventually worked for us is no chunking. So what we did is, since we know that the default chunking was not working, we split the files per user. So there would be a file called Sandeep at AntStack, which is going to have all my feedbacks, and similarly, different files for different users. Now, we uploaded that to S3 and gave it as no chunking. With this, what happens is, the vectors that gets created are based on an individual's file. So my file becomes an individual vector, and when I run a query based on my user, it is going to refer to only that chunk of information and then summarize on top of it. You also have other chunking options available. Based on the use case, you can experiment with different types of chunking and see what results you're getting. So once you select the type of data source and what parsing and chunking you need to do, you just need to select what is the embedding model that you want to use to convert the JSON or the data into a vector array. So these are the options that are available right now. And then you go for a vector database. Now coming to the vector database, there is an option called quick create. In this, you don't need to do any kind of configuration. You just select your S3 as the data source. It will create the OpenSearch collection. It will do the embedding. It will dump the data. All that is taken care by AWS. Now, after the reInvents update, Postgres SQL is also added as part of the vector databases. And if this is not the case, and you already have a vector database created, then these are the available options or available databases which you can link with the knowledge base and say, this is the database that you want to use. And once you select that, it will ask you information for the ARN, the connection string, all those information which it needs to connect to the actual database. Once you finish the configuration, then you go into the chat screen. Now, you can see the data source that we have created. It is from an S3 file. Once this is created, you need to click on that and say sync. When you press the button sync is when the data is actually taken from an S3, converted and embedded and stored in the database. Until then, it just does the configuration required for it and any kind of infrastructure that it needs to create. All that is done, but your actual data dumping happens when you click on sync. And this sync is also exposed via API. So when the application is progressing, as the data gets uploaded, you would want to keep syncing the data to have fresh information for your AI. So every time you upload or every time the data gets updated, just call the API and tell it to sync, and it is going to update the latest information, and your AI is going to have access to it. And once you start testing the knowledge base, you have different search types. You have a hybrid search and you have a semantic search. The semantic search is based on text, and the hybrid search is based on text and other information as well. In our case, hybrid search worked, but again, feel free to experiment with different types and see what works out for you. Next, you have the number of source chunks. So this is a very important parameter. What it does is, when you ask a certain question to the chatbot, you tell it how many responses it needs to process. In our case, since we had already split the file based on user, it's just one file per user. So the first response is the best response, or the first file is the best file. So we wanted only one chunk of information. But based on your use case, you can increase this number up to 100 and see which data source works, or which number works best for you. Next, you can also create a knowledge base prompt. So apart from the actual chat that you're doing with the chatbot, you can also provide a particular prompt for the knowledge base alone and tell it, provide it more context. So this context would be like information on what kind of data is there in the source and what it needs to do or how it needs to run the query to get the information out. So all these customizations can be done as part of the knowledge base. So this is the result of the initial test we ran. So for a particular user, when we ask a query, let's say, what are my top 3 points of improvement, it's going to fetch the file or the data for Manik, and it is going to summarize all that and say, these are the things that is doing good, not doing good. Same goes for me as well. So based on my information, it's querying the database and telling these are the things that is doing good and this needs improvement. So once this was done, we integrated this part of the application. We gave the access to admins. So as an admin, I can see everybody's profile, I can see everybody's result, and we started using this to give constructive feedback. It also got into our quarterly reviews, yearly reviews, everything. Then we wanted to see how we can provide this for other users as well, like whether we can enable this chatbot to everybody. There was one problem with that. As an admin, I should be able to query everybody's feedback. But as a user, I should be able to query only my feedbacks. I should not be allowed to query somebody else's feedback. So how do we do that? How do we put a restriction in place such that it works perfectly fine when a question is about myself, but it throws an error telling I'm unauthorized if I'm asking a question about somebody else? That's when we started experimenting with agents. So as part of agents, again, Bedrock has an agent console where you can get started. So as part of the agents, you provide a prompt. Now, in our case, what we did was, we are telling it the instructions like, you're going to get a particular question, and you're going to get an email ID in the question. Now, what you need to do is identify if the question is for themselves or is it for somebody else. Now, if it's for themselves, take a particular action. If it's for somebody else, take another action. And you can also configure memory as part of an agent. By default, it is disabled, but based on the use case, you can enable it. Now, for an agent, these are the things you can configure. You can configure an action group, which basically invokes a Lambda. You can configure a knowledge base, the one that we previously created. You can use that, or you can create up to 5 knowledge bases, if I'm not wrong, and tag them over here. Now, the agent will have access to all of this, and based on the prompt that you're going to write, it is going to selectively call or access this information to provide the result. So in our case, we went with an action group. So for the action group, you define a set of schema, and you tell what Lambda it needs to use. And for us, the Lambda, we are mentioning that it needs to have 2 parameters as input. One is the query type, and one is the email. So the query type, the value can be only self or others, and email is the email of the requester. And this is what we told in the prompt as well. You identify whether the question is about themselves or others. If it is themselves, call the action group with query type as self. If it's for others, call it with query type as others. This is the basic Lambda. It's just taking the input, and if it's for others, and if that person is not an admin, you can also do other stuff, like if you have the admin list stored in a database, because Lambda will have access to the database, you can call the database, get an admin list, validate that list, and if the user is an admin, we are telling it to continue. If the user is not an admin, we are telling it to end the process. And it'll show a text, something like you're not authorized to run this request. So after all this is done, we tested it out. So the email ID in the first one is a dummy email ID. It's just random at AntStack. And it says list Sandeep's top feedback. Now once this goes to the agent, it will identify that this person called random is not part of the admin list, and it will tell to reject the request. And based on that, the chatbot will provide an output, something like you're not authorized to do this. But if the same thing I run from my own email ID for my own query, it will give the feedback that I'm looking for. So this is how we leveraged agents to have an admin level control on what kind of responses we want to get and who needs to access what data. So with all this done, we integrated this part of the application. Everybody's using it and getting a good sense of how they're doing and what are the things that they can improve on and stuff. Now we wanted to see what other things can we do with this data. And we got a little ambitious, and what we did was a chatbot where you can ask questions about your career. Even something as crude as, will I get my promotion next year? Can we answer those sort of questions with a chatbot like this? Was what we wanted to get through. And that is when we started a concept called divide and conquer. It's basically having multiple prompts, multiple LLMs, and multiple data sources, lambdas, all those things. All of them orchestrated together using something called as a prompt flow. And based on the designation, based on their current skill set, it is going to evaluate everything and say, these are the things that you need to do to get your promotion. So we start off with prompt flow. So prompt flow is, again, a service as part of the Bedrock, which allows you to orchestrate different things. You can add different prompts, lambdas, S3 sources, and with the recent update, there are also a bunch of other things that you can add to the flow. It is basically a glorified step function, if you guys have used step function. So the first prompt does an audience identification. What it does is basically identify whether the question is from a particular user and what is the query, right? Then it goes into checking the user role. So this one tells whether the query is for self or the others. It's very similar to the one that I showed previously. And then the Lambda queries the database to get a list of admins, identifies whether this person is in the admin list, and based on that is going to say proceed or end. That's the output that is going to come out of this Lambda. Then you have a conditional block, which basically says, If it is proceed, go to the prompt section. If it is end, then end the execution with a catch, or with an error statement telling you're not authorized. Next, we go into a classify question. Now, what this prompt does is it identifies what kind of question you're asking. If the question is about their feedbacks, it classifies them into a particular variable. And if the question is about a career, it will mark that and send that as an input to the next stage. So the next stage is the knowledge base that we created previously. So irrespective of whether the question is about their career or their feedbacks, we still need to query the knowledge base because it has the information on what kind of feedbacks this person has received. So we will gain a lot of insights from that. So that is always mandatory. Then it goes into a Lambda function. This is where the magic happens. So we get an input over here which says what kind of query it is, whether it's career or feedback. If it is feedback, it's only going to process the feedbacks and send that as output. But if the question is about career, then it will start querying other information. It will query the person's technical skill set. What are the ones that we have evaluated the person on previously? It could be an Excel sheet, it could be a database, it could be any source that we have. Then we also get the information on what is their current role. Let's say internally we follow MTS 1, 2, 3, 4. So we get their current role, and we have information stored on what is required for a person to go from MTS 1 to MTS 2. What are the skill sets that we're looking for? It could be technical skill sets, it could be soft skills, anything. All that information is stored. So we pull all this data in this Lambda and send it to a final summarizer prompt. Now what this prompt does is it takes in all the information that we have provided, and it creates one beautiful summary which says what is this person doing and what this person needs to do. Now this is the first example where a user is trying to access somebody else's information, so they're not allowed to do it, so it's rejected. Now this is the second case where a user is asking question on their feedbacks. So it is going to query the knowledge base and provide the summarization of it. And this is when somebody asks a question like, how to improve my career? Now for this information, Akshay is the email ID that we have used. That person is currently an MTS1, member of technical staff 1. And his next role is, of course, MTS2. And this provides, firstly, what are the strengths. This is cumulative of all the feedbacks that this person has received. Then it provides the areas of improvement. What are the things that he can be improving on, right? And then it tells, to improve your career, what you need to do. This is, again, accumulation of the feedbacks and our MTS expectations of a particular engineer. And if you have noticed in the question, we are also asking, what are my setbacks? Now, for Akshay, based on all the feedbacks that he has received, there are no negative comments, or there are no drastically negative comments, so there are no setbacks as such. So this is the level of information that you can provide or enable for your users. Now, so before we go into pricing, so with all this in place, our 360 feedbacks or our quarterly reviews, yearly reviews, everything is now less subjective and more objective. We always refer to this chatbot, and based on this information is when we provide constructive feedbacks and tell them this is what you're doing and this is what you should be doing. And once we did this for a while and encouraged everybody to start using this chatbot, that's when it got better. Then an employee didn't have to necessarily set up a meeting with their manager to know how they need to improve their career. They just started using it themselves. And they started telling their managers in the reviews that these are the things that I have done. Now I'm ready to be an MTS2. What's stopping you? So coming to pricing, like every other LLM service, Bedrock is charged primarily on the number of tokens you consume based on the LLM that you're using. If you're using knowledge base, you're costed for the open search that it creates, the amount of data open search has and stuff. but there's no explicit cost for using knowledge base itself. Similarly, the logic applies to agents as well. There's no additional cost for using the agents, but rather you're costed for the LLM that it consumes and the lambdas, other data sources, knowledge base, all the underlying resources that it creates. It's something like CloudFormation. You are not charged for CloudFormation, but you are charged for everything that you use as a part of its deployment. Now, the time taken for development of this. So when I started making this presentation, I wanted to retry everything from scratch to see how much time it will take. To do this entire presentation and all the services, deployment included, took me less than 2 hours. That is how easy it is to get started with Bedrock. Everything is automated to a very large extent. All you need is a proper data source and a logical understanding of what you need to do. That's it from my side. Thank you.
Hello. Is it audible? Yeah. So what I wanted to ask is, you mentioned about the 2 hours, but in actuality, I think you would have iterated it multiple times, right?
Yeah, but
So
when you look at the actual prompt, the time it took to write that prompt is fairly straightforward. The time it took for me to understand how to write the prompt is when it took time. So by the time I started doing this, I already know the basics of what it needs to be there, right? The persona, the roles, the positive cases, negative cases. So I know that these logical structures need to be in place. So once you know that writing the prompt is easy, or to make it more easier, you send the basic version of it to ChatGPT. It's going to tell you, it's going to give a sample prompt, and that works just fine.
Okay. So cumulatively, like from the start when you created this, after the multiple iterations, what to the version that you're using right now, how much time might have actually been taken?
I think it took about 5 months or so, because once we had the data, like for 3 months, we didn't know what to do with the data. And until 3 months, we didn't know if the data really made sense. Yeah.
Yeah, thank you.
Yeah.
So the question is around pricing. You mentioned it's similar to CloudFormation where you charge for the resources that you use.
Yeah.
So if you could just try and share in a bit of detail of which areas are sort of expensive. I understand Bedrock has, or Bedrock uses things where you have tokens that you charge for. But apart from the token thing, are there any additional pricing comparisons that we have to understand for an example of this sort?
Yeah, the biggest pricing factor is the actual vector database. So if you're using OpenSearch, for example, even though it's a serverless collection, there's a minimum running cost associated to it. So that'll come up to, I think, $160 or so per month, even if you're not using it. So that's the biggest or the most expensive part of the entire system.
Can you recommend some best ones to choose from, like other than OpenSearch? Let's say I have to store a large number of documents as a knowledge base, and my users of that application are something like a marketing people or business analyst who wants to know about the features that are there in the product based on those documents. So these kind of queries are coming in. So
yeah, so Pinecone is really good, and even OpenSearch is good. But for your use case, it depends primarily on chunking, like how we are going to split those files. If you split them too small, then the output does not make sense. If it's too large, then you get unwanted context as well. So you need to experiment with different chunking sizes to see what gives you the best result. And any interface you can use to easily test out that would be the first thing that you need to do. Before even going to what kind of vector database you should be using, you should be focusing more on what chunking limits you need to apply.
thank you.
Anyone else?
You mentioned about the use of agents and the prompt flow.
Yeah.
But in the prompt flow, do you think that is more of like a controlled way of defining what to do, rather than if you give freedom to LLM to decide, right? If you, based on your bigger, even if it is a bigger prompt, using a custom instruction, if you are able to have that classification by the instruction itself, then that will be more, that will give more freedom for your solution, right? Rather than being stick to a prompt flow. My question really is that, do you see any value in using prompt flow?
Yeah, I got the question. So the larger your prompt gets, the lesser it gets in precision. So that's why when it gets to a certain level, we always split the prompts. So another example is we participated in a hackathon uh, where we ingested 800 GB of data and to the LLM and all those things. But when we tried to fit all that information in a single prompt, like what it needs to do, like how it needs to identify XYZ, it started failing. It started running in loops. It started having timeouts. It was giving incorrect data. Even when we said, I want, say, 5 people out of the entire lot, it used to give 6 people, 7 people, sometimes 2 people. So, but the same thing when we split it and started using it efficiently for like a single task purpose, then we got better results. So if your prompt is getting very large, and if it needs to do a lot of things, the base logic is to split them.
Thank you so much, Sandeep, for this. I would like to invite Tinsy to hand over a gift as a small token of our appreciation. Please, everyone, a round of applause.